All right, so this unit we're continuing on with our linear theme. We're learning about linear equations and linear functions and the relationships of linear things. And today we want to talk about linear regression or lines of best fit. You'll hear it called that a lot. You'll also hear it referred to as a trend line. That's another thing that you might hear it referred to as. In the real world, we're dealing with data. Lots and lots of data points. And the whole point, we live in a data-driven society. And the reason we like to have data is that we can look at data and figure out if there are relationships or patterns in the way that things are behaving. And then we can use the data we have from things that have already happened to kind of predict what would happen in a certain situation. It's really a lot of fortune telling when you really get down to it. We're using the data to help us figure out what is going to happen. And so when you look at data in the real world, very rarely does data perfectly fit a shape. But a lot of times it will have a general direction that it is going. So for example, if I'm looking at a set of data and I plot the data points, if I have a set of points that look generally like this, that's not a perfectly straight line. However, it is kind of going in this general direction. It's not perfectly straight, but we would call this we could call this a linear relationship. These points are kind of all over the place, but for the most part, they are kind of hugging that line or kind of following that line. Some are above, some are below, some are on it, but the data in general is moving in that way. This is what we call a correlation. The points may not be in exactly a straight line, but they are moving in the same general direction. And so if we can come up with a line that kind of goes through the middle of all of that data, we would call this the line of best fit or the trend line. So the deal with the line of best fit is that it does not touch every single point in the data necessarily. But it kind of goes through the middle of the data, and it is going in the same general direction as the data. If you have data points that when you plot them, they could be kind of all over, like kind of going down like that. Not a straight line, again, but it is going in that general direction. And so I could say, okay, so a line of best fit might go through here. Now, if you ever take AP statistics, someone did come up with an actual statistical way that we can get the best line of best fit, other than just eyeballing it and guessing and trying to figure out, okay, what's the line that goes as close to the middle of this as we possibly can, and that is called regression, linear regression, and that's a statistical analysis. But thankfully for us, they have taken that statistical analysis and they have programmed it into things like computers and spreadsheets. And so we don't have to know that statistical analysis just yet until we take AP statistics and figure out what is the line of best fit for a set of data. So if you go on your calculator, there is a way for you to put data into your calculator, and then it will find the equation for the line of best fit. And the equation of a line of best fit is we usually call the model. It models that data. If you're ever doing a problem and they ask you to find a model, what they're asking you to find is the equation for the line of best fit. Because if we have that equation, we can plug numbers into it, we can make predictions, and those sort of things. So I want you to look at this set of data over here. This over here is a record of someone's incomes over that 30-year period and how much their income went up over those 30 years. And if we wanted to write a model for this data so that we could predict what they would be making maybe in another 5 years or in the next year, we could do that. When you go into your calculator, if you go to Stat, that's the button that you want to hit, is Stat, and then Edit comes up. And when you go to Edit, what it does is it gives you tables. And so you can enter information from a table. So I've got this information that I can then enter into the table. One thing that I do want to point out, generally you'll just take data as it is and you'll put it directly into the X column, make L1 be your X column and L2 be your Y column. but sometimes you won't want to do that, especially if there is a year. If there is a year, then what you're going to want to do, that's 1,980. We don't want to do math by plugging in 1,980. That gets very cumbersome. So a lot of times what you'll see is statements like let t equals 0 or x equals 0 be 1980. They'll usually give you a starting point. And when they do that, they're basically saying, okay, let 1980 be 0. So 1985 would be 5, and 1990, well, that's 10 years later. And then 1995 would be 15, and 2000 would be 20, and 2005 would be 25, and 2010 would be 30. And so when I'm putting my data in, instead of using the year 1980 or 1985, I'm going to change it to make that year be 0. Now, generally, you make your life easier. If it starts with like 1982, just go ahead and make 1980 be 0. And then 1982 can just be 2. And then 1983 would be 3. And so basically, we're counting how many years has it been since 1980. And when I go into my calculator, that just makes for smaller numbers for me to be doing my calculations with. So for my X column, I would put in 0, 5, 10, 15, 20, 25, and 30. And notice I just typed each number and put enter. And then I go over to this column and I need to put its matching income. So this one was 60,000, and then I had 65,000 and 72,000 and 75,000 and 85,000 and 87,000 and 92,000. Another thing you can do is that if this is income, you could make it in thousands if you wanted to also make them smaller numbers. And then I would just type in 60 and 65 and 72 and 75 and 85 and 87 and 92. You just want to make sure that when you do that, you're consistent and that you do it with all of your data points. But when you go into stat, remember it's stat and edit, the information that you type in is saved. You don't have to hit like a save button. It automatically saves. So as soon as you hit enter and enter a number in, it's saved in there. And so then you can just quit. But if you go to stat and instead of going to edit, go to calculate, down here you'll notice choice number 4 is linear regression. Linear regression, lin-reg. And you'll even notice it has like the mx plus b formula, except they use an a instead of an m. The ax plus b formula, and if I choose linear regression and hit enter, it's going to give me the equation of the line of best fit that goes through the majority of those points. So this equation for the line of best fit was y equals 1092.86 plus 60,178.57. All right, so notice on the calculator they give you A and they give you B, but it's y equals ax plus b. So A is the slope and b is the y-intercept. And so this is the equation of the line that would go through all of those data points. Now, you can graph those on your calculator, but graphing the scatter plot and graphing the linear regression equation on the calculator is not something that's necessarily terribly handy or quick. What you're going to find for linear regression and taking data, your calculator is great, especially on things like a test, because for the most part, tests, standardized tests, end of course tests, they don't let you use a computer on that, but you can use a calculator. So you can use your calculator to do a linear regression. Things that I want you to remember is that once you have this equation, I can use it to plug things in. So for example, I could say, so how much do you expect this person to make in the year 2015? Well, 2015, if I added it to my chart, would be the 35th year. And so I could take this equation and I could say, okay, so 1092.86 times 35, because that would be the year 2015, plus 60,178.57, and I could make a prediction about how much I would expect this person to be making in the year 2015. So 1092.86 times 35 plus 60,178.57. So I would expect this person to be making roughly $98,428. So $98,428.67. And it is dollars because that's what we were counting in. So that's what I would expect this person to be making. So again, the whole point of getting these equations, these regressions, is that once we have this model, we can use it to make predictions. We can plug things into the equation and figure out what they're equal to. What I wanted to show you is that we don't always use a calculator. In fact, for something like your project, or something that you have a lot of data, you're probably going to want to use a spreadsheet. So there's a couple of different types of spreadsheets out there that are available to you. If you have the Microsoft Office suite, Excel is the name of the spreadsheet program. If you're using our Google apps, there is Google Spreadsheet. So if you go to Google Docs and choose New, it asks whether you want a sheet or a doc or a form. It's Google Sheets. So if you use Google Sheets, it will take you to a spreadsheet as well. When you're looking at your spreadsheet, you want to realize that all the spreadsheet is it's a big table. So it's already set up for you to put in your data into rows and columns. It's also set up so that you can add different sheets. So for example, in your project, you have, and if you click down at the bottom, see this is sheet 1. When I go and double click on that, it will let me say, okay, well, I want this one to be my volume versus weight. Because if you remember in your project, you have data for the volume versus weight. But we also had individual data about the weight versus time. Weight versus time. And maybe this is my spreadsheet. Okay, so weight versus time for Miss Parker. But then maybe the other members of my group have their weight versus time for Miss Hellman. She's another member of my team maybe. Or I can add a sheet for where we have our groups data. So this could be weight versus time for the whole group. And so I can set up a page for each one of these so that they're all in one saved document, one saved spreadsheet, and I don't have to have like 20 different documents and files that I'm opening. They're all in one file and one thing. What's great is that you can always just make your tables. Okay, so this was our volume, and we did our volume in milliliters, or you converted it to liters, and then we did our weight. And I think when we did our weight, we had them in pounds, but you guys are converting it into kilograms. Okay, so this could be our information. And so if we found that 2,000 milliliters was 10 pounds, or we found that 3,000 milliliters was 12 pounds, or 5,000 milliliters was roughly 30 pounds, something like that. We can put our data in here. If we're looking at our weight versus our time, for me, what if my weight that I was carrying versus my time? So this was my weight in pounds, and then this was my time in minutes. Now this is where you have to be careful. If you've done your time in minutes, please remember that if it was 8 minutes and 38 seconds, I can't put 8.38. It was 38 seconds out of 60. So that's a fraction. And so you're going to need to make sure that you convert that into the appropriate decimal. So for example, when I'm putting in my weights, let's say for 35 pounds, that my time was 8 minutes and 38 seconds. So when I'm doing 8 minutes and 38 seconds, I'm doing 8 plus 38 divided by 60. And so that's going to be 8.63 minutes. So 8.63 minutes. Do make sure that you're careful with that conversion. Let's say that 33 pounds took me 7 minutes and 45 seconds. So if I do 7 minutes plus 45 seconds divided by 60, it's going to be 7.75. 7.75 seconds. And so I want to make sure that I'm very careful with those. So now I've got 19 pounds, took me 6 minutes and 28 seconds. So 6 plus 28 divided by 60 is 6.47. 6.47. All right, and you can put in your data points this way. Let's see, I think I've got 2 more data points here that I can put in. All right, and then I've got 27 pounds was 849. So 8 plus 49 divided, 8 plus 49 divided by 60 is 8.82. And 11 is 434. So 4 plus 34 divided by 60 is 4.57. All right, 4.57. There we go. So those would be all of my data points. Now don't forget, when you are doing your whole group, you're basically taking all of my data points, all of my team members' data points, and then we're putting it into one long list of data points. This whole spreadsheet acts as a large calculator. So when you want to make your spreadsheet or you want to do your linear regression, all you have to do is highlight your data. Click and drag and highlight your data, and then go to charts. And then you can insert a chart. All right, so you've got your information here. You have to choose different things. So for example, chart types. We want to make sure that we choose a scatter plot. We want to make a scatter plot. So this would be our scatter plot. We can do some customization to it. Make sure that you have a title. So this is going to be my weight versus time for Mrs. Parker. Okay, and I don't like the legends, but you can have a legend over there. You can change your font, you can change your background colors. There's lots of different features. Here's something that you should always have. You should always have a title on your axis. So my horizontal axis here, that was my weight in pounds, and I want to make sure that I label that. And then we want to do, let's see, then we have to go to our vertical and we have to title it, it was our time in minutes. And so that was, I labeled my two things. So now I have, you should never have a chart that doesn't have labels on it. That's always a bad deal. And then when you come down here, you can choose how many grid lines you want to show. Like I like to show minor grid lines, so it looks a little more like graph paper. You can customize that to show whatever you want. And then down here at the very bottom, you have to scroll all the way to the bottom of customization. You should see trend line. And I mentioned that line of best fit, another name for it was trend line. You can add a trend line, and we in particular want to add a linear trend line. And when you add it, notice it will give you the equation or the line right through your data points. It's great. You can see how many of the points it touched. Notice I've got a couple above, a couple below, and that one, it almost touches. All right. And then when you do that, one of the things that you want to do is that you want it to, let's see, trend line, linear, label. At label, you want to make sure you say use equation, because what that's going to do is that it's going to actually give you the equation of the line, and it should put it on the actual chart. So it will label it with that. So use equation, and then that should, there we go. So you do have to have the legend showing up in this one. On Excel, you don't, but if you make sure that your legend is showing up, then your equation will actually show up, the equation for your trend line. Now, it's really great is that it will let you touch your trend line and actually see what things are equal to on it, which is fantastic. But once you finish all your customization and hit insert, then you've got this lovely little table and chart. You can copy and paste this into presentations or documents. You can take screenshots of it and use it in a PowerPoint or a Prezi, but it gives you a nice scatter plot. You don't have to have like graph paper or presentation paper or anything like that. You can actually put this into a Prezi or a PowerPoint or something for a presentation. And you can do that. This is in the Google spreadsheet. Again, the upside to using a Google spreadsheet is that your whole team has access to it. I make this one spreadsheet and I can share it with my entire group. And so I've gone in and done mine, but then Ms. Hellman can go in and she can type in her data and make her her chart and her spreadsheet. And then as long as we've both gone in and typed our data in over here, one of us can go and click and turn that into a table while the other one's turning this one into a table. So, you know, I could go in and I can click this, and as long as I've highlighted it, I go to chart, and then I go to chart types, and I make sure that I scroll down and I choose scatter plot. And then I go to customization, and I give it all the information that I need to, like the title is going to be volume versus weight. And we've got our legend and our font. If we don't like it, we can change it. And then we can make sure that we give all of our, so my horizontal is my volume in milliliters, and my left vertical is my weight in pounds, and it already set that for me. I've got my major and minor grid lines showing, however many you want. And then I can go to my trend line, choose linear, and then for my label, I make sure I use the equation, and it will do that. Now, don't be shocked when this shows up. That is scientific notation. That big capital E means that this is 7 times 10 to the negative third power. That means it's 0.007. So anytime that E shows up, it is just giving it to you in scientific notation. Please make sure you're paying attention to that. And then I can click insert, and I've got my table. So if you don't have a graphing calculator at home and you're trying to do your homework for linear regression and take the data and find the regression for it, you can use Google Sheets, and it will give you the equation for the line of best fit. So if you don't have access to a graphing calculator at home, you can use that. We do have graphing calculators in class. You want to make sure you learn how to do stat edit, stat calculate, and put that information in, because that will be a skill that we're going to be using throughout the year.